Hey, good people, welcome back. This is Arthur Morris. I hope that all is well with you today. In this video, we are going to look at expanding logarithmic expressions. Logarithmic expressions. So we'll use the product rule, the quotient rule, and the power rule to expand the logarithmic expressions. All right, so let's look at a few examples here. So the first example we have here, we want to use the properties of logarithms to expand each logarithmic expression as much as possible. Evaluate logarithmic expressions without using a calculator if possible. All right, so we have log base b of x to the sixth power times z. So the first thing that I see is that I need to use the product rule. The product rule. All right, so we have log base b of x to the sixth power plus log base b of z. All right, now I see that we have this exponent of 6 in this first term, so I'm going to use the power rule to bring it out front. So we have log 6 times log base b of x plus log base b of z. Okay, let's look at another example. Here we have log base 3 of the square root of y. So using the quotient rule, I can rewrite this into two separate logarithms. Keep in mind that the square root of y is the same thing as y to the 1/2 power. So now I have log base 3 of y to the 1/2 power minus log base 3 of 27. So in this first term, I can use the power rule again and bring the 1/2 in front of the logarithm. The second term, I can evaluate that because, again, we're asking ourselves 3 to what power equals 27? We know that 3 times 3 times 3 equals 27, so 3 to the third power equals 27. So this entire thing evaluates to be 3 because 3 to the third power, that exponent, is that answer there. All right, simplify. Let's try another one here. So on this one, we have log base b of x to the third times y, all divided by z to the fifth. So the first rule that I'm going to use is to undo the division. I'm going to use the quotient rule. All right. Now, in the first term, I have log base b of x to the third times y. So there I can use the product rule to separate those variables again. So remember, with the product rule, we separate by using addition. And I still have the minus log base b z to the fifth. Okay, so now I have log base b of x to the third, log base b of y, and log base b of z to the fifth. And since we have those exponents, the final thing we'll do is to use the power rule. So my final answer would be log 3 times log base b of x plus log base b of y minus 5 times log base b of z. Alrighty, let's look at one more example. Alright, so we have the natural log of x to the 7th times the square root of x squared plus 8 all over x plus 6 to the 8th, or x plus 8 to the 6th power. Okay, so the first thing that we want to do is to undo that division by using our quotient rule. And remember, the square root of that x squared plus 8 is the same thing as x squared plus 8 to the 1/2 power. So the natural log of x to the 7th times x squared plus 8 to the 1/2 power minus the natural log of x plus 8 to the 6th power. Okay, now the next thing I'm going to do is to look at this first natural log there and separate that again because I have x to the 7th times x squared plus 8 to the 1/2, so separate it by using the product rule. Okay, and then the final step, we have those exponents and we want to pull those down in front of the natural logs by using the power rule. And again, this is lowercase ln for natural log. And that would be that expression fully expanded. Alrighty, good people. I hope you found this video to be helpful. I'll see you on the next one. Thank you.